Hello and welcome to today's webinar in partnership with Styrenics Circular Solutions, Fraunhofer Institute and INEOS Styrolution, hosted by Packaging Europe. In today's special 90-minute webinar, we'll explore the circular potential of styrenics, including polystyrene packaging, and take stock of the value chain's progress in closing the loop for polystyrene packaging. So my name is Elisabeth Skoda. I'm the editor-at-large here at Packaging Europe. For those of you who are unfamiliar with Packaging Europe, we're the leading intelligence resource for packaging professionals around the world. Via our website, as well as online and in-person events such as the Sustainability Awards and Sustainable Packaging Summit, we deliver daily news content, authoritative comment and analysis, case studies, and high-profile interviews with leading industry players, and enable communication across the packaging value chain. So a bit more about today's webinar. In recent years, the polystyrene value chain has taken decisive steps to realize the circular potential of its packaging by developing a range of innovative recycling solutions. And these solutions are currently also being scaled up. And today we will explore how they allow to respond to a demand for safe and sustainable materials required by EU laws such as the PPWR. And that includes recycled content requirements for food packaging. We'll explore how the value chain has been closing the loop for polystyrene packaging in practice by safely recycling it back to food applications. And our speakers will talk us through the intrinsic functional value and circularity potential of styrenics, and we'll also discuss how scientific studies confirm the safety of recycled polystyrene food contact material. We'll explore the evolving EU regulatory framework, how the value chain has been adapting to it, and how collection, sorting, and recycling capacities for polystyrene have been developing. So with that, I'm very pleased to welcome our speakers today. We have Dr. Frank Eisenträger, who is ECO and Market Development Manager at INEOS Styrolution. We have also Dr. Frank Welle, who is Head of Department Product Safety and Analytics at Fraunhofer Institute. And we also have Ken Hustebeck, who is Policy Director at Styrenics Circular Solutions. And yes, coming up next today is Jens Kattmann, who is Secretary General at Styrenics Circular Solutions. So before I hand over to our speakers, just a little bit of housekeeping. There is some time, probably about 20-25 minutes reserved at the end of this webinar for a Q&A. And using the chat facility, please put in your questions and I will put them to our speakers at the end of this session. You can do this throughout the entire webinar, and obviously we'll try and get as many of your questions answered as possible. And for any technical questions, please select the support button, which you'll see on the left-hand side of your screen. So yeah, with that, I'd like to hand over to Jens Kattmann, who will welcome you on behalf of Styrenics Circular Solutions. Thank you.
Yeah, thank you very much, Elisabeth, and also from my side, but first and foremost, on behalf of SCS, our board, our members, and last but not least, you will learn them in the coming minutes, our speakers. A warm welcome to our webinar, Polystyrene Circular Food Grade Ready Now. So you will remember some of those building blocks in the coming minutes. And I would say before the K, the timing today is a bit on purpose to give an update on the progress of our industry, and in the next minutes also showcase a bit the achievements coming soon. So having said that, and without further delay, I'd like to transfer to Dr. Frank Eisenträger to then take it from here. Over to you, Frank.
Then good afternoon from my side. I'm pleased to guide you through the functional intrinsic values, which basically means the reason why we use PS in dairy packaging. And I mean, I start with one with probably most of you already know because we have emphasized that so many times. It's the ideal material for multi-pack yogurt pots because of the snappability, so you can easily break one off, and that is the easiest with polystyrene and a bit more difficult with all the other materials. but it's also the fastest material to process it on the line, actually, because you can bring the heat quickly in and also quickly out, and it doesn't need to be pre-dried. So that is exceptional also for PS. Leading to it's the easiest to process of the materials which we can use for dairy packaging. A converter once told me I can wake up any of my employees at 3 o'clock in the morning and all would be able to process polystyrene, and probably none would do the same at that time with the other materials. So it's just much more difficult. If you look to lower to carbon footprint, then because there is not that much energy we need to bring into for thermoforming and also out again, there's actually a relatively low scope 2 at the converter side, for the FFS processing. If we think about recycling and especially chemical recycling, then depolymerization has an advantage over pyrolysis. It's a short pathway, it leads directly to the monomer and has much less energy involved. And last but not least, I would like to mention that also on the virgin, the fossil materials, there is a strong footprint reduction agenda. So on the pathway to net zero, there will be strong reductions even there. High material efficiency, I think this again is quite known again. Polystyrene is a very stiff material, so you can work with it in very thin films, and it is solid and stiff enough to be a yogurt pot. And then this leads us a bit to recycling. Polystyrene has a big variety of recycling methods available. So we can use mechanical recycling, we can use depolymerization, dissolution, gasification, pyrolysis. All of this is possible and actually mostly available. And all of them lead to food contact materials at the end. So these were the functional intrinsic values. Now a deeper look into recycling. The PS waste quality is actually extraordinary. Why? Because most of the objects that we find in the waste are white, and second, they are nearly all food contact. That is very good to start with. Another point is that the material has not suffered because it was typically, as a yogurt pot, only 30 days in the fridge. So it is not that the material properties are weakened or so. So they are just the same as they have been at the very beginning. That means then also if we go to the recycling, we come up with the white material and we have the full freedom of design. So we can again print it like we want. We can convert it into a FFS cup, or we can convert it into single cups, or we can do K3 cups. So anything more or less is possible. In the recycling again, due to the signals of polystyrene, the NIR, so near infrared technology, is perfect to sort polystyrene cups. There are clear signals, so you can distinguish different materials very easily, and this leads then to a high purity of the recycled material. Well known is that black articles are not distinguishable in NIR, and this is actually what we don't have in polystyrene. So there are nearly no black yogurt cups. RPS, mechanical recycled, or even by other technologies, are drop-in solutions. So if you have a process running, then you can take the recycled material and just run the same process. And typically, you don't even have to adapt a lot of parameters to run that material. So, and the recycling can take multiple cycles. So we have tested up to 10. We could go further, I think. So there is no concern, as the material properties are typically kept within the recycling, and there's very little degradation. So then coming a little bit to the science part. So why is polystyrene so made for recycling or made for food contact? And one of the main reasons actually that it's a low diffusion material. What that means, if you have any kind of contamination or a colorant or something like this, it does not enter into the polystyrene. And this is pretty much the same property as we have it in PET. If you look carefully at the chart, you see that's even slightly better. And if at all a contamination manages to get into the polymer, then it has the same very hard time to get out again. So that means after being recycled, it will not release the contaminants to the food. And this is what it makes safe and perfect for mechanical recycling. There's one difference to PET, and this is that our applications in the dairy industry are typically refrigerated and have a quite short best before date. So it's not like a water bottle that might be at room temperature for a year somewhere, but it's typically 30 days at fridge temperatures. And this is just an additional safety and makes polystyrene recycling very easy. So now that was the introduction into the science part, and I would then hand over to the real scientist. And Frank Welle, your turn. I think you can give us a much better insight.
Thanks, Frank, for this invitation. In the last couple of years, we conducted several scientific studies, and the purpose of my presentation is to give you a brief overview over these scientific studies. First of all, when we started these scientific studies, we looked into the EFSA evaluation criteria. So as you maybe know, EFSA has not published evaluation criteria for recycled polystyrene till now, but as we learned from the last slide of Frank Eisenträger, polystyrene is a low diffusive polymer. So most probably EFSA will apply, let me say, similar evaluation criteria than those for mechanical recycled polymers, like PET. So EFSA is looking into 3 pillars, which you see on the right-hand side here. So the first pillar is the determination of the worst-case contamination level in the input material of the recycling process, so typically in washed flakes. The second pillar is the cleaning efficiency of the decontamination process. This is typically determined by a so-called challenge test with artificially contaminated flakes. And the third pillar is the assessment of the consumer exposure, typically based on food consumption data. And all these 3 evaluation criteria are typically done on worst case assumptions. And the fourth worst case factor is the migration modeling, because migration modeling is typically overestimative. So let's look into these 3 pillars. So first, the initial contamination levels. So we have done a study which is published this year, beginning of this year. So we investigated 49 post-consumer packaging waste batches collected from 6 European countries over 1.5 years. We looked into these misuse applications. So we found that 1 out of, let me say, 10,000 individual flake samples show evidence of misuse. So the incidence of misuse is therefore 0.0097%. We found here in 1 sample alpha and beta pinene, so solvents, at a concentration of approximately 700 milligram per kilogram. So the initial contamination level is then 0.069 milligram per kilogram in post-consumer washed flakes. We published also a list of the top 30 substances which we find in these 49 samples, and in the conclusions of these publications, we suggest an initial concentration level of 1 milligram per kilogram in post-consumer flakes as an initial contamination level for the evaluation. Let's look into the second pillar, the cleaning efficiency data. Here we determined in the last couple of years lots of cleaning efficiency data for several processes. 3 of them were used in dossiers according to the old regulation. So, for example, NGR, Noise, and INEOS, the Revolution, has submitted dossiers to EFSA. So EFSA has these cleaning efficiency data, but the cleaning efficiency data are not published till now. We can use these cleaning efficiency data now also for the novel technology dossiers, and in this study, we may also try to suggest more realistic overestimative factor. This is the reason that we have then a more realistic migration modeling, and then the cleaning efficiency will be much lower. Looking into the exposure data, so the third pillar, here we made some, we looked into some applications, for example, cold-filled yogurt, hot-filled yogurt, trays for meat, fish, and cheese, trays for food in general or vegetables, and then cups for cold drinks and hot drinks. In the second column, we looked into the food consumption data. For example, for yogurt cups, it's 250 gram yogurt per day per person. The third column is then the storage temperature. So we applied here realistic storage temperatures and time. So for example, for cold-filled yogurt, 14 days at 60 degrees Celsius, so a typical shelf life under fridge conditions, and so on. And then in the third column, we can then calculate the exposure to the consumer. So for yogurt, it's 0.1 microgram per kilogram. And this is then the maximum migration value after a challenge test, for example. In the last column is then a factor of 5 applied as an overestimative factor for the modeling. This is applied also for mechanical recycled PET by EFSA. And then we use this last column, the values in the last column, for calculating the minimum cleaning efficiency data of the super clean processes. This is shown here in the next slide. On the left-hand side, it's the published data. In the published data, we published this study in 2023, so 2 years ago. We assumed here an initial contamination level of 3 milligram per kilogram. Based on the new data published this year, we recalculated it to an initial concentration level of 1 milligram per kilogram. This is shown on the right-hand side. So these are the minimum cleaning efficiency data the super clean processes have to reach to make a safe recycled for 100% recycled content material in the yogurt cup or in the other applications. So the next slide is then on functional barriers. This is also a publication from 2023. Here we looked into the co-extruded yogurt cup with the recycled material in the core layer, and then a virgin layer out as a functional barrier layer. The test is more or less similar to a challenge test. So we spiked the surrogate directly in the core layer. We have for functional barrier, it's important to have also a pre-storage time. So the test included also a pre-storage time of 14 months, also worst case, so a very long pre-storage time. And then we measured the migration. We applied here a gas phase kinetics, so we make a migration kinetics into the gas phase. We cannot make this kinetics into yogurt. It's better to have these gas phase kinetics. We cannot use in this case migration modeling because we expected that the functional barrier layer, the virgin layer, is contaminated due to the high temperatures during the pot manufacturing process. And as expected, we find this contamination of the virgin layer. But the migration amount, which we have determined after 40 days at 60 degrees Celsius, meet the very low migration limit of 0.1 microgram per liter for a functional barrier of approximately 20 micron. So my last slide is then a conclusion. So we have performed several studies. We published the data. And these studies confirm the safety of recycled polystyrene in direct food contact as well as behind functional barriers. All these studies are conducted under worst case assumptions, and the results are published, except the cleaning efficiency data, but these data are also available by EFSA. We can use now these data also for novel technology, and it's up to EFSA now to assess these scientific data.
Happy to take over and talk a bit about the EU regulatory framework in which we operate. We are focusing here on two aspects. The one is the EU PPWR, that's the packaging waste regulation that will harmonize the requirements that all packaging has to meet across Europe. This is already adopted law, as most of you will know. It has entered into force. Its rules apply at different times regarding different requirements. And the first very relevant requirement is that packaging must be designed for recycling. That refers to, simply put, technical recyclability. And you see here that, in principle, from the start of 2030, 70% of a packaging unit must be technically recyclable. That's a, so to speak, firm requirement. If your packaging at that time does not meet the requirement, then it is not allowed on the European market. On top of that minimum requirement, you will see in more and more EU member states also the eco-modulation of extended producer responsibility fees, EPR fees. That are fees that must be paid for the packaging and then are higher for less recyclable packaging and lower for more recyclable packaging. That's the meaning of eco-modulation. That has actually been foreseen in principle in the EU Waste Framework Directive since 2023, but now we see this coming more and more, and this will also be harmonized under the PPWR across Europe. So what are part of the solutions that the polystyrene value chain can offer? We have designed for recycling criteria. For example, agreed upon members of SCS, then the colleagues from Plastics Recyclers Europe have them in RESI class for polystyrene packaging as well as for EPS packaging formats. They will also be harmonized by the European standardization body SEN, with effect or adopted likely by the turn of the year. So you have these reference documents that give you a relatively clear guidance what exactly to do. And then on the technical side, for example, our members have developed a so-called mono-PS pot that increases also the yield from polystyrene recycling. And at the same time, we have also improvement, of course, of the polystyrene recycling processes. That's one requirement. Another requirement is to be recycled at scale. You see that requirement will be effective later than the technical recyclability, because it is also quite challenging actually for almost all plastic packaging, because you see what it means. It actually means that at least 55% of the packaging in the given category that is placed on the European market is effectively recycled, meaning comes out of the recycling process. But also here, we have been successfully working on solutions. They must include the mobilization of the full value chain, and this is already and has already been happening. In many cases also initiated or strongly supported by the users of polystyrene packaging, for example, in France, or more recently in Spain, as well as many other relevant markets in Europe for polystyrene packaging. Then the next requirement is recycled content. So you see here again the timeline starting from 2030. For example, in polystyrene yogurt pots, you must at least incorporate 10% recycled content, and 25% is then the requirement that will apply later in 2040. This is not specific to PS yogurt pots. This is the minimum requirement for what the legislation calls contact-sensitive packaging. That includes all food packaging, unless it's covered in another category. For example, PET is another category with higher recycled content. But because polystyrene yogurt pots, for example, fall in the category of contact-sensitive packaging, the 10% minimum recycled content applies and will be required. On top of that, you already have in an increasing number of EU member states, so to speak, inducive measures. Meaning, for example, in Spain, there's a plastic packaging tax. You are excluded from that tax or exempted from that tax if you use recycled content. That tax sits at 450 euros per ton currently, so that is somewhat an incentive to use recycled content. And very recently, France adopted a law that entails that between 450 euros and in the future up to 1,000 euros for contact-sensitive material, meaning also for food packaging, will be granted as a bonus on the extended producer responsibility fee. So this is money that you save or even kind of, so to speak, get back if you place packaging on the market and incorporate recycled plastic in it. And here also really the technical solutions as well as the already realized solutions in the market that my colleagues will present in a few minutes really help and actually are ready now to meet this requirement. So also food grade recycled polystyrene is available, as the colleagues will present very concretely. Let me already now say something that I will repeat again. And this is also prior to a positive opinion by the European Food Safety Authority, EFSA. And just to conclude on the packaging waste regulation, we, the industry, have to meet all these three requirements: design for recycling, recycled at scale, and minimum recycled content. We will get some support from the member states under the PPWR. If I may kind of draw your attention in particular to the bullet points here in green. So the member states must ensure a separate collection of all packaging, and packaging complying with the design for recycling criteria must be collected for recycling, and the member states may not continue its landfilling or incineration. So all this packaging that will be designed for recycling is supposed to go into the recycling. Then I come to the regulation of food contact material, or recycled plastic food contact material to be more specific, and that includes the recycled plastic that goes into food packaging. Maybe in particular for our attendees from outside Europe, it's very important to note that since the end of 2022, we have had a new regulation on recycled plastic food contact material in the EU. And you see what timeline has developed already under that still new regulation. And I will only point out a couple of things that we, SCS, our members, and the polystyrene value chain, as well as other value chains, have had to do, and which in our case we also really have done. So in April 2023, we completed a notification of a so-called novel technology to the competent authority. That's an authority of the member state and the European Commission. That involved a lot of preparatory work that Dr. Weller has hinted at. At the same time, when we completed that notification, we also had to publish a so-called initial report, which is basically the public version of that dossier. So that was a very important first step. Then, for example, in July 2023, the recyclers using our novel technology to recycle polystyrene into food contact material had to send something called the compliance monitoring summary sheet to the competent authority, and they have since been audited. Their installations have been audited by the local competent authority. That roughly coincided under the new regulation with the end of the general very short transition period. But also since then, recycled plastic food contact material has remained legal if and as long as the novel, so-called novel technology procedure that I actually kind of have illustrated here is followed. And that's the case for polystyrene. Then in October of 2023, for example, our novel technology passed the verification period by the competent authority. And as expected, we did not receive any objections. So the technology, our technology, or the technologies that we know of our members have been verified by the competent authority. Then we have had to already publish 4 monitoring reports that report on the safety of our technology. And after the 4th report in April this year, we were then in a position to request an EFSA assessment. That request currently sits with the European Commission. And with that, I come more or less kind of to the next step, to the future. You see that in only actually a couple of days' time, we will also have to publish our 5th monitoring report, and that reporting requirement will continue to apply. And with that, really, we have been doing everything that is required from the industry to produce safe recycled plastic food contact material. And it is now in the hand of the European Commission to initiate the EFSA assessment. Then EFSA will give an opinion. As Dr. Weller has implied, we expect that EFSA will give a positive opinion on the safety of our novel technology and other polystyrene recycling novel technologies. And then the Commission will take the legally binding decision. What is very important to understand, and therefore I stress again, is what you can see at the bottom here in the green box. The recycled polystyrene, the recycled food contact material produced with the novel technology is permitted currently on the European market. And that is also before EFSA completes an opinion on it. And this has been confirmed also by the European Commission when responding to questions, for example, asked by some authorities. You will find the link here. We will provide you with the slide deck so you can check those responses by the Commission yourself. And with that, I would actually like to hand over to Jens, who will speak about, first of all, the bigger picture, what SCS mission is, and then also concretely how we have organized this work on so-called novel technologies. Jens?
Yeah, Ken, thanks a lot. And always a good transition to my following part here. We come a bit more from the, let's say, overall picture on circularity and closed loop recycling, exactly to what it means for polystyrene, for recycled polystyrene. What you see here is applicable, of course, to polystyrene, but also to all other polymers, but crucial to close the loop on the way to circularity or to full circularity with closed loop recycling, and to go through all the stages. Frank also, if you remember his presentation, talked already on drop-in solutions, on multiple recycling technologies, food contact safety, also elaborated by Ken. This is the upper right, what you see here, food contact suitability of RPS. And this slide and the circle also nicely illustrates how crucial it is to tick all those boxes, all those circles on your way, and important, and also since time is of the essence to achieve that, you have to work in parallel. So it nicely illustrates our narrative right from the beginning, which we have in SCS until today. So I will also not go through all the stages which I mentioned here, those phase gates of the value chain, but the drop-in by converters, the positive support by brands and retailers, the collection and sorting to create the market pull and to align with the capacity scaling at early stages is crucial. We come now, as you said, from the more generic overview to the, let's say, meaning for PS and RPS technologies. Basically, best is to read the slide from right to the left and follow those arrows. But also, again, I like to start with what Frank said on multiple recycling technologies and the meaning and use within polystyrene and recycled polystyrene. You see on the right the different collection sorting steps you can take. The most, let's say, applicable also to move forward is to go for separate collection and sorting and direct to the mechanical recycling for food contact, or you go then via the mixed plastics or even mixed plastics waste and come to, let's say, depolymerization, and also what you see on the outer left here, the chemical recycling. For us at SCS, chemical recycling is recycling of mixed plastics waste, but I like to mention also that with the last week's official launch of Inderware, we are focusing on depolymerization and the plastic to plastic recycling, which you see here, or the plastic to chemicals, which is also then applied back to monomer. So this is what we use and also applied SCS. The good news here, I think, is first of all, number one, that all technologies are already in place and operation. That, of course, the separate collection and sorting as well as the mixed plastics or mixed plastics waste is ongoing, you know that. And I think the important second part also here, and that what you see, that next to the high versatility of polystyrene, recycled polystyrene, it's great to have more than one recycling technology in place, which we have. We have multiple. And also from the complexity and from the market needs and the scaling economically at scale, you can choose and pick and have the freedom of choice here on those technologies. And last but not least, and you see it in the punchline, all those technologies come at a very favorable carbon footprint and at low energy, again, from right to left, the energy consumption is increasing. But again, you are also able here to position yourself with your technology in the best, to say so, corner in order to apply those technologies together with the value chain. So I think that's great news. And again, an older slide, but still valid today. And as we now see and know, it's also now completed by recent announcement towards what is coming with the PPWR, as just explained by Ken also. To the next slide then, slide number 25. This was mentioned by Ken, and also a specific, more specific look on the regulatory developments, the regime as explained, the 2022-16, which gives the opportunity to already apply novel technologies on their way to suitable technologies, and therefore also being able to place already material on the markets. What you see here on this slide is our famous SCS consortium, the ABA developer consortium, and the members in this consortium. We have, and we are proud of that, 15 members in this consortium, SCS members and non-members. And it nicely shows that there's, let's say, also another way to get into recycling technologies and also scaling of capacities while you embrace the value chain and also use positively the EU regulation, being fully conform and compliant to that. So basically with that, it was mentioned by Ken, we are now on our 5th monitoring report. We have already applied and requested the European Commission for EFSA assessment. You saw those timelines as explained by Ken, which of course apply. But as we are in operation, as we are going on the market, again, there's a famous work in parallel. By means we are on the market. Later on, you will see also some, let's say, proof points and evidence by Frank Eisenträger on that, how we do that. And in parallel, of course, we push for the EFSA assessment, which we trust is rather solid and robust. Again, I like to refer here to Frank Welle. I think he explained very well and very comprehensively why circular polystyrene has such a unique position also in the circularity of polymers. And this is for that time my last slide, so I hand back to the next speaker.
Good, then I can happily show you that this is not all just theory, but already in practice. And I'll show you this with the next slide. Here we go. So we are on the market. Also, Jens said that already. Since earlier this year, this is a Lidl yogurt cup. This is introduced into the German supermarkets. Interesting to me is that actually the white labels are the first early adopters, so to say. The reason why it's done, I mean, we are in the year 2025, not yet 2030 when the PPWR comes into force or comes into with the need of the recycled content, is that we prepare for PPWR. Yeah? So that cannot be done overnight. We need to check the different packagings and so on, and that is, I think, one of the most important targets. But also at the same time, there's a move towards fulfilling the SBTi targets for footprint. This, of course, triggered an intensive collaboration between the packaging converters, the dairies, us, and also the supermarket. So this cup was the first. It was submitted for the PRSE Packaging Award in Amsterdam, made it amongst the finalists, and yeah, was a very nice success. It is produced with one of the novel technologies we mentioned. Actually, it's the novel technology of immerse dilution for the direct food content. The second pot I want to introduce you, we are as proud of that one. Also in the German supermarkets. It's in German supermarkets because it's linked to the dairy, I would say. That is the only reason. That is an Aldi cup for sour cream. Aldi is very active also on the waste side, no, with their dual or the EPR system. So they secure the waste and they want to bring it back into the supermarket, and that was one of the first projects here, which we show. Also here, 30% recycled content is introduced. I've seen also already some of the questions around the 30%. I mean, 30% is already 3 times higher than what is enforced by the PPWR. So it's a very good trainings exercise. And we have to remember also that typically up to now that comes at a bit higher cost, and therefore, yeah, you might not immediately strive for the 100%. But one or the other technology will allow for 100%. Also, that should be being said. The picture on the bottom of the right was taken just a few days ago at the Fachpack Fair in Nuremberg. So this is where we received in the consortium, so Aldi, Müller, and Ineos Styrolution, the German Packaging Award in the category Sustainability. And the next slide is actually one that, should explain a bit what we have tested. So there's intensive testing behind. A lot of testing has been done in cooperation with Müller here in those two cases. So we checked the color. We try to be as white as possible with our solution. Actually, a lot of customers tell us, oh no, can be also different color. It doesn't matter if recycled is different, but to begin with, we started to do really white. We checked migration with all different kinds of solvents, and we checked the print quality. So can you print as easily on the recycled polystyrene as on virgin? All the processing parameters, of course, and I mentioned to you that it's more or less a drop-in product, but of course you look at this very carefully. Most important actually is not only migration, but also smell and taste. So if there's anything negative concerning smell and taste, that would rule the solution immediately out. We did packaging tests. That means, can you stack one pallet of yogurts onto the others? Is that stable? Will this crunch the bottom layer? And how does this behave in transport? Transport testing. So this is what we have all done. You see, quite comprehensive. And yeah, with that being said, I hand over and back again to, let me check, to Ken.
Yes, thank you, Frank. And with that, I will just go relatively quickly over some data. I stress again, you will receive the presentation afterwards, so you can also then go back to the sources that we provide. The data that I will present basically answers the question why polystyrene packaging is on track to being recycled at scale in Europe. So let's look at also, and to start with, what polystyrene waste feedstock is available for recycling. And I have to stress here about all this data. There are always kind of assertions, private studies and reports going around, and that's very well. What nobody has, actually, for hardly any or none packaging category in Europe, is actually official granular data for all European markets at a polymer level. So for example, for PS packaging, but you also will not find it for other packaging categories. However, what we use here as example is actually official data from those member states that already voluntarily publish such data. And here you therefore have the example of Germany, who has reported on its packaging waste system for a bit longer. This is specifically for or on separately collected polystyrene household packaging waste. So, for example, in particular, the polystyrene yogurt pots in Germany. And you can see that there is some volatility, but it's a rather actually upwards trend without the Germans having changed in those reporting years anything in their waste collection system. Yeah, but nevertheless, they have found and reported more separately collected polystyrene household packaging waste. Do you have many other countries, some of which I will come back to specifically, that have only quite recently started separately collecting typical polystyrene packaging formats? So when I say that, I mean, for example, yogurt pots, regardless of the polymer. Then in the next step, is the polystyrene household packaging waste being sorted? Yes, and in an increasing number of large-scale sorting plants. This is really just a selection. It's in particular very recently reported additions to the sorting capacity, including for polystyrene. And you see, for example, the very large-scale project, so-called Site Zero in Sweden. You see new sorting plants for household plastic packaging waste in Austria. And then you also see on the left-hand side, for example, a lot of capacity in Germany. In one specific case, in Bremen, actually, it came online. Then unfortunately, there was a fire due to a battery, but that plant has now been repaired, so it's online again, which also helps keeping the recycling rate of polystyrene relatively high in Germany, because in Germany traditionally 2/3 of the polystyrene household packaging that is separately collected under the extended producer responsibility scheme there is directed towards recycling. And that's, again, official reporting that you can also then find through the links that we provide. Maybe one comment on France. And you see here also different countries also have somewhat different approaches. You see lower capacities, but that's because all this capacity is in so-called oversorting plants. That means that it is a secondary sorting step. And France has decided to use such a system where specific waste streams, including polystyrene, are sorted in those oversorting plants that have very recently come online. Then about the recycling capacity in Europe. We have older surveys amongst European recyclers from McKinsey that, for example, found that 1/3 of them would process polystyrene back in 2020. At the beginning of 2024, the colleagues from Plastic Recyclers Europe actually commented on their report that polystyrene recycling is taking off. Just to be fair also to the colleagues, that was on the, in particular, 2022 data. And they reported that in early 2024. Of course, since then, there have been some concerns that unfortunately had to be also voiced very clearly about the state of the European plastic recycling industry. But that was kind of the observation. It's a direct quote, and you see also in the numbers in the illustration why the colleagues said that, because they found from 2019 to 2020 and then to 2021 each year actually more than double the capacity for PS recycling in Europe through their surveys and other research. And since then, the growth of identified polystyrene recycling capacity has been coupled, so to speak, to the overall market. You see on the right what kind of, from the most recent data available from Plastics Europe, will be the future. That is the additional capacity for food contact material recycling, including but not limited to depolymerization as a capacity, as just last week inaugurated by Indava in Antwerp. And with that, I come to an example for the equally growing recycling rate of polystyrene. So that's not only about the available capacity, but actually about the capacity used to recycle polystyrene. And in this case, the official data comes from the Belgian Household Packaging Producer Responsibility Organization that's responsible for organizing that recycling. And if I may draw your attention here to the illustration on the bottom right, we have taken this actually one-to-one without any changes from FOSPLUS report. The only thing that we put in there is a frame around the column for polystyrene recycling. As you can see, it sits currently at about 50%. However, I think it's noteworthy that these 50% have been achieved in Belgium within 3 years from typical polystyrene packaging formats being separately collected across the country. So, of course, some preparation started certainly before that, but it is a clear example that determined action can scale up polystyrene recycling in a few years. And you might also then have already kind of grasped that there is room for improvement, but that room is being filled in Belgium and beyond. For example, through the optimized, improved design for recycling of XPS trays, very concrete example here from the Belgian market. Further improving collection, of course, this still needs to be improved because it was extended to more and actually virtually all household packaging only quite recently, and the additional capacity in Antwerp, in Belgium, to recycle polystyrene. By the way, also the official reporting from Germany indicates actually a similar effective recycling rate for separately collected polystyrene household packaging of just under, in that case, 50% already now. And with that, I would like to hand back to Jens.
Yeah, thanks a lot, Ken. On this slide, after having talked a lot on our achievements, our industry, and also the path forward, also important to somewhat have a look on the outside in, to say so, how we are perceived by others. And basically, what is better than proof points, evidence, or testimonials, or even ratings or certificates by reputed sources. So we have picked here 4. I read them quickly, but I read them because they're all quite impressive. At the upper left, in conclusion, from an LCA perspective, the K3 pot, Frank mentioned that the PS pot and the regional reusable glass can be recommended. So this is from NGO NABU. So for us, those statements matter. We can argue that there's a wide landscape of LCA and eco profiles, but the one we have from NABU surely matters to us. Then staying on the lower left, if the sorting volumes in the EPR systems are too low, we ultimately gain nothing. Shouldn't all yogurt pots therefore be filled? Shouldn't all yogurts therefore be filled into PS pots? This is Aldi Nord. Again, I like to recap on what I said on the importance by retailers and by brand owners and their perception. And again, for us, it would be more than a vision, having all yogurt in PS pots. But again, I think the properties of polystyrene and the dairy packaging are not disputed. Upper right, PS is a great success story thanks to food contact approval and the progress the industry has made. The PPWR made rice switching from PP, PS rising from the dead. So we know who made this statement. It's one of those commodity intelligence services, which you all very well know. There are 2 or 3 bigger ones. It was one of the bigger ones. But again, it explains also here from a, let's say, agency, intelligence service agency, if they being fed by informations by their members and their clients communicate like that, very positive also for the polystyrene development. And the last one is a bit, PS might be the dark horse of circular packaging. But it explains very well. This is made by Greiner, SCS member. The way we came, the turnaround we managed, because when we started, SCS indeed was more of the outsider and maybe pronounced almost dead. But what we see, and especially what you heard today, of course, it summarizes nicely what is meant by the statement by Greiner. On the next slide, and this is more on the existing and the future, a call for further action and collaboration. As said, the value chain, the collaboration, the working in parallel is of high importance to really achieve those milestones and get forward. So what we really have to do, and this is valid for both basically polystyrene and recycled polystyrene, we see it as a plus, means virgin polystyrene plus circular will also lead to, let's say, additional volumes, incremental volumes. There's no substitution as such in the market if everything goes well. And therefore, the stabilization of the volume is important. Why it's important, not only for, let's say, feeding the capacities, but also if we think back into collection and sorting to really generate feedstock from both and also feed in then what we said earlier, recycled content, because in order to do that, you also need a well-established, let's say, virgin market, and then building up recycled content to really then go for circular polystyrene at recycled content levels, as it was explained by Frank, of 30% or even more in future. So this will increase the demand for recycled polystyrene. As I said, it's a combined effect positively, and also promotes the sorting of PS packaging, as explained by Ken, to have all, let's say, actual and coming sorting lines equipped for polystyrene as an important component of the collection and sorting is rather important. But again, here, tick in the box to the extent, as explained by Ken, we are well presented. Also mentioning here the larger sites running at larger capacities. Polystyrene is also separately collected and sorted in those lines. And last but not least, and this is the transition also to not only what we do today with this webinar, but also on the way forward, what you see SCS and our members, our industry, for instance, in social media, is communicating the progress, delivering on those milestones, also positively communicating on those success stories, in order really also to further accelerate and motivate our value chain, and also move forward the progress even faster than some of you might perceive it today. It always can be more, it always can go faster. We are already quite happy what we have achieved. However, if you look at regulatory aspects and market penetration with our products, of course, we like to see further acceleration in order really to generate more sustainable and circular products from our industry. Having said that, on the communication, and this is really a short call, follow us, follow SCS on our website, on social media. We have a lot of substance to exchange, to talk about, but we also let's say, refer to our members and also third-party progress in order really to feed the substance here for social media, for press releases, for the benefit and for the future achievements of our industry. And this is close to our heart. We do that. So just the call is follow us and repeat, and also distribute those positive news through those media channels. And I think this, if I'm not wrong, was more or less the last slide of the part of Ken Üstebeck and myself. And we now enter into the next session. Back to you, Elizabeth.
Yes, thank you very much, Jens, and also to Frank Eisenträger, Frank Welle, and Ken Üstebeck for really interesting presentations and for giving us insights into the potential of polystyrene. So it's now time to head into the Q&A section of this webinar. But before we head to the audience questions, I'd like to benefit from having all of our speakers on stage together to see if any of you had any comments or points to raise or anything to say about what the other speakers have shared in their presentations. So yeah, I'd like to give the floor to you for a moment to see.
I think we had
none from my side because of also all the interesting questions that we have seen coming in, which seem to focus quite a bit on actually food contact materials. So they align very well also with the focus of our presentation. So maybe we can tackle those. But Frank, you...
Yeah, I think we got a broad overview, from regulations to science and a few practical examples. The missing things are probably the questions, and I would encourage the public to go over the questions and distribute likes, because that will help us to prioritize, and then we get the most important first.
Yeah. Same here. As I said in my last slide or previous slide, we talked a lot about our achievements, about the progress in the various areas, and the webinar also is meant to invite the audience for questions and comments, which also again should encourage us to work even harder on the progress. Yeah.
Perfect, thank you. So yes, I'll now head into the audience questions. We've had quite a lot of these, or rather very many questions come through. So, but obviously I keep them coming. Any questions we don't get to, the Packaging Europe team will collate them and pass them on to the SCS and Fraunhofer and INEOS team, and they'll be very happy to get in touch with you and answer them. Yes, as after the event. So yeah, you don't have to worry about your questions not being answered. Okay, so let's get into the Q&A. And we had one question coming in asking, PS recycling, for example, coat hangers, flower pots and trays and office equipments, as well as construction materials, is already established. Why do you focus so much on the food contact material? Yeah, maybe that's one for you, Frank Eisenträger, but obviously you can all chip in.
Yeah. Nice question. So basically, I'm very happy that PS is already being recycled into flower pots and hangers and so on, because that means that the whole recycling industry, sorting and all this is in place. So that is important, because if you want to start from scratch, it's very difficult. But second is PPWR. PPWR simply asks for incorporation of recycled materials into food contact packaging. And then we said, well, which material is the best suited? And a lot of people said PET, we said PS. So, and I think we have shown that the PS is really very much suited, and therefore we do that. No? So then we take the PS into the food packaging probably as much as possible. And if then one of the flower pots has to be produced out of PP, so be it.
Yeah, Yeah, I think to chime in here, Frank, absolutely. First of all, again, we need all recycling. Not everything goes into food contact. If this is the second meaning of the question, but also for us and looking at the markets, and also what was mentioned, the regime and the fact there is PS predominantly in use. As we said and demonstrated, it's a huge potential, huge market in dairy packaging. And of course, here from the PPWR, but also in general, we have to support this business also by delivering on recycled materials, recycled content. And here, of course, the challenge is and was the food contact, which we do. But again, I like to say also other recycling activities are important. Even cross, let's say, recycling activities between EPS, XPS, and polystyrene are important. And at the end, it's an overall, let's say, balance we have to achieve here with our recycling activities. Yeah. So therefore, we do everything, which is somewhat the blunt answer on that.
That makes sense, thank you. And another question we had through, has polystyrene not been disappearing from the market? How can polystyrene possibly meet recycled at scale and recycled content requirements?
Yeah, maybe I pitch first here, but invite the others to comment. Yeah, indeed, yes. I mean, it depends on what year we locate that. But as I said earlier, when SCS started, we were close to really entering into a disastrous development, having not enough, let's say, recycling capacities, technologies in place. And therefore, the question in a way is correct. 10 years from now or 8 years from now, it was really rather the question, do we manage a turnaround? We were somewhat, to say so, standing at the edge of the cliff, yeah. But as explained and as all can see, under pressure, also a lot of positive developments in rather short time span were developed. Also technologies which were there. We further developed them, for instance, for food contact, and managed the turnaround together with our value chain, with our members, and really the strong styrenics community. And I think it's time for a thank you to all those supporters, to all those companies who are believing in polystyrene, its properties, and also made this happen what we see today. Because today, as you could see from those testimonials, polystyrene is one integral part of recycling activities. There's no polystyrene discussion anymore, as it also was 7-8 years ago by NGOs, by others who were rather critical. Right now, we don't hear those critical voices anymore, which again, I think is a good sign, but will not make us lean back also that we do not keep pushing further in demonstrating the recyclability of our products.
Yes, thank you. And yeah, related to the questions of recycling, somebody asked us, we hear a lot about European plastics recyclers being in crisis, and will polystyrene recycling actually survive it?
Yeah, should I go first again? But I'm talking otherwise. But also on the last question already on recycling at scale, there's something which transfers also to this question of survival. I think indeed you have to slice a bit the question and say, if you look at mechanical recycling, indeed we are, as we say, at crossroads in a way, also driven by regulatory and maybe upcoming situations facing imports, and also, let's say, the SME status of those recyclers, which financially are not that much in a positive scenario to overcome too long with those situations. So yes, it's a watch out. It's not a watch out only for polystyrene. It's a general watch out for the mechanical polystyrene as such, mainly also by regulatory, by imports, by missing classifications and all that. But I would say on the other side, you have to take those positive spins already. Inderwear, for instance, was mentioned earlier as a capacity now being launched. This somewhat by curbing positively accelerating collection sorting of materials recycling activities should also benefit, let's say, the overall recycling, the feedstock and the availability of materials. But again, at this point in time, we need some further development in regulatory aspects, I would say mainly on the import situation, to somewhat positively protect, sometimes a bad word, but to somewhat protect the mid-size recycling industry from running into cash problems and perhaps even bankruptcies. This is a situation as Plastics Recyclers Europe, to cite the organization here, sees it today. Yeah.
Absolutely, yes, thank you. On the similar subject of recycled content, somebody's asking us, we hear that the EU rules on recycled content are not being enforced anyway, and will companies really comply with them? Maybe that's one for you, Ken.
I'm happy to take this. Yes, we have kind of seen such comments or headlines. I must admit that they irritate me quite a bit. Let me ask you back, have you experienced amongst your friends ever a personal income tax audit? And if not, does that mean that you do not pay taxes anymore? It's a little bit like that. Now, I can understand where this comes from, but regarding recycled content, but you also have to see the differences between the recycled content targets for PET beverage bottles that come in Europe from the Single-Use Plastics Directive. These are targets addressed to the member states. Yeah, so the EU law did not even require directly that, for example, each company placing PET beverage bottles on the market must use recycled PET. The member states still had to do that. So that's the first difference. Under the PPWR, it's a directly applicable requirement that directly applies to the manufacturer that places the packaging on the market. That's one thing. Then about being enforced. So basically, we have not seen any fines being handed out. To be fair, you have to look there actually at the legal system of each of the member states. So you have to get this expertise. And I can only answer right now for my own home country, Germany. The fine foreseen under German legislation for not including the required recycled content, as I said, right now that applies only to PET beverage bottles, is 10,000 euros. One could say only 10,000 euros by default. The problem that you have if you are the obligated party, the company who had to incorporate the recycled content, is that it can be or maybe 10,000 euro per bottle. And then, of course, you might be in really big trouble. And furthermore, actually, the German law states that any profit that you gained from not complying with the requirement must be exceeded by the fine, or may be exceeded by the fine. So the overall fine might be much higher and could in the future really get you in big trouble. So at least this example shows it is not impossible to foresee fines. Then second, these fines have not been enforced, is I think also another thing that I've heard or read in some places. Yes, but frankly, that's also just, so to speak, fair. In Germany, in the German transposition of the Single-Use Plastics Directive, the requirement has applied since the beginning of this year. However, in Germany, and that's also similar to the PPWR in the future, a company may average this actually over a year, and it has to show after the book year ends with the end of this year, for example, for the first time, that in its books it has bought enough recycled material to meet for all the bottles that went out from that company the recycled content requirement. So, of course, Germany has not yet enforced this. It would be completely unfair now to knock with the police at the doors of the companies because they still have until the end of the year to balance their books. That's called averaging. So you have to look at this a bit more closely, and therefore the short answer is, frankly, all the companies must now really start preparing for complying with the requirements of the PPWR, because you have to imagine that they will be enforced just as any other legal requirement. And normally you do not accept the risk to be non-compliant. So I think this is the answer, and the short answer is yes, we actually kind of expect that the companies who want to stay in business will comply.
Makes sense. Thank you, Ken. All right, let's continue with a few more of the questions that were really popular with our audience. Someone is asking, when can we expect EFSA opinion on recycled polystyrene?
Very quickly, by standard or by default, 1 year after the Commission initiates the EFSA assessment. As I've said, the Commission has not initiated it, and that's actually all we can say about that specific step. For polystyrene, we can be maybe a bit more optimistic that EFSA might be able to conclude more quickly, because as Dr. Weller has presented, polystyrene mechanical recycling technologies were already in front of EFSA. EFSA already has the recycling and decontamination efficiencies for those processes. And many of the novel technologies that have been notified are based on the same processes. And that might then actually expedite the EFSA assessment. Again, that's, I think, everything that we can say at this time. And except for the important part that, as I stressed, the EFSA opinion is not required for placing the recycled food contact material, meaning here the recycled polystyrene in food packaging on the market. And because I saw a question asking what's actually the source of that, the source of that is the regulation itself. I could point to multiple provisions, but for the purpose of this question here, let me see. Let me pick Article 4, Paragraph 5, where you can see that it says whether recycled plastic material and articles are manufactured using a novel technology, the requirements laid down in Articles 10 to 13 are met. And the EFSA assessment is Article 14, so it's not referred to as a requirement. This is how law works, and this is not a typo, because the Commission has also put it in reflected that in other provisions of the regulation, as well as confirmed it. And you can find the document in which the Commission has confirmed it behind the link that we used in our presentation.
Great, thank you, Ken. Another question we had was, is there a perspective that recycled polystyrene, in brackets mechanical or chemical, will be approved for food contact in the future?
Thanks. I will quickly take this again. It depends or actually, it does not depend on what you mean with approved. If you mean, is it allowed now? Then the clear answer is yes. And actually, in both cases, in the case of chemical recycling depolymerization, that is treated by EU regulation, so to speak, as good as virgin. So you don't have to go through any novel technology procedure, notification procedure, or the like. For mechanical recycling, that's then novel technology, and what I just said and explained applies. This material is already permitted insofar and as long as you follow the novel technology procedure. And we expect in the future a positive opinion from EFSA as well as then a subsequent decision by the European Commission, making that novel technology actually a so-called suitable technology.
Thank you very much, Ken. Somebody else is asking us, there are many process technologies for food grade recycling polystyrene packaging. What's the industry's best choice for future investments?
I think I can take that one. That's a very subjective question because everybody might come to a different opinion here. So, well, this is what at the end we call market, no? So might the best technology win? On the other hand, they are very largely complementary. So if we typically take the example of mechanical recycling and depolymerization, chemical recycling, mechanical recycling brings a polystyrene yogurt pot to exactly the same thing again, so a polystyrene yogurt pot. Sounds very perfect, but the chemical recycling brings actually different aspects. So you can use different feedstocks. You can take protective foam or XPS trays or the like and bring it back to styrene. And the styrene we can then bring not only into polystyrene for yogurt cups, but we can bring it into applications of healthcare, of automotive, of ABS, of ASA, so be it. So there's a much broader variety. And so that shows that actually the two technologies complement themselves. But nevertheless, I mean, they come under different conditions, they come with different prices, and at the end, we will see in the market what will prevail.
Great, thank you. And somebody else is asking us, just lost it for a moment, sorry. How about EPS foams? Are these recyclable?
I'm happy actually to take this because it's a very easily answered question. Yes, and they are not only recyclable, for example, EPS transport packaging, but they are already widely and successfully recycled in Europe and beyond. Much of the EPS transport packaging is or becomes commercial packaging waste and is as commercial packaging collected for recycling, and as I said, already recycled in practice. And on that one, you don't only have to trust me or other industry organizations. For example, even the United Nations have confirmed that last year in a report.
Great, thank you. Okay, we have probably time for a couple more questions, although the next one I can see is quite multi-pronged, but we'll see how we go. Well, the question is, how's the price compared with virgin polystyrene, and what is the supply capacity? And how would you know if the feedstock you collected came from virgin or already has been recycled twice? Does that have an impact on the quality? So there's 3 questions in one there, but
I can try to tackle them. So first of all, do we know if the feedstock came from virgin or from recycled? No, we don't know this, and it doesn't matter. So we checked it. You can recycle it minimum up to 10 times. There will also be always an influx of new polymer, at least in the next 10 to 15 years, as far as I can look now. This will be the case. So doesn't make any difference, so it doesn't matter. When just happening again, now that I don't get lost.
There was also a question about how's the price compared with virgin polystyrene.
How's the price? That first of all, it depends on the technology. So there might be different prices with the different technologies. Second, everyone says, yeah, mechanical recycling or chemical recycling. Anyway, it's always too expensive because often it is more expensive than the virgin plastic. That is indeed the case. I say this is typically the case because of the scale. So with virgin, we have much larger scales, and we also have much more years of experience than with the recycling, which is relatively new and not yet at the same scale. But we have different industry actors on the different technologies, so there is competition, and there is already a certain scale developing with respect to PPWR. if you ask myself, I'm convinced that we will meet or that industry will offer the recycled content to satisfy PPWR. And therefore, I think then also the prices will over time come down, and we see that today. I understand the concerns. No?
Great. And I think there was the final bit of that question was about the supply capacity.
Yeah, I alluded to it. So I think in 2030 we will have sufficient capacity. Actually, I would say even much earlier, we will have sufficient capacity to fulfill this 10% recycled content requirement.
Perfect. And yeah, I think we've got time for one more question because before it's time to wrap up. Somebody's asking us, one second, is the new RPS Aldi cup from Müllermilch this technology?
This technology is nice. The question is what technology? But the Aldi cup is actually the INEOS dilution novel technology for direct food contact.
Perfect,
This is just one example. I mean, it was a very precise question.
Fantastic, thank you. So yes, I think unfortunately that's all we have time for today, so it's time to wrap things up. Thank you everybody for joining us, and yeah, like I mentioned before, don't worry if we didn't get the chance to answer your question today. We'll collate all the questions and pass them on to the Styrenics Circular Solutions team and all the other speakers, and I'm sure they'll be very happy to answer your questions. So this webinar will be available on demand within the next couple of days, and you'll be able to you'll be sent a link to access it in case you want to recap anything you've seen today. And yeah, that just leaves me to thank all of our speakers, Jens Kappmann, Ken Hüsterbeck, Dr. Frank Welle and Dr. Frank Eisenträger. Thank you very much everybody, and goodbye.